everyone. All right, this is our last lesson, quadratic applications. So when we did our quadratics unit, every unit previously we've done some kind of application problems, and actually quadratic applications are, I think, the most realistic and the coolest ones that we talk about all year. And I saved it till the end. So hopefully you guys, try this stuff, and hopefully it goes well, because I think they're actually really cool. All right, so for our notes this week, I'm just going to do 2 examples with you guys because, we know how to do the quadratics part, hopefully. And then this is exactly what your quiz is going to look like. So here's our first example. So example 1. The height of a baseball over time is modeled by the following equation. H equals -16t squared plus 80t plus 3. So I just want to go through, and for any quadratic application like this, the letters mean something. So if you can guess, t represents time. And 99% of the time in applications for quadratics, the variable is t for time. H, well, they tell you, right, the height of a baseball, so h represents the height of the baseball over time. And they'd also told you time, but, and so there's a bunch of questions, so I just want to go through and read the questions. What is the initial height the ball is struck by the baseball bat? So let's think about initial height. What's the height of the baseball after 2 seconds? 3 seconds. How long does it take for the ball to reach a height of 50 feet? And how long does it take for the ball to reach the ground? And so there's all kinds of different questions, but all we have to think about is what is the shape of a quadratic graph? And we can really just think about that in terms of if you were playing baseball. So I'm going to draw a little picture over here, and I'm going to do my best to draw a picture. So let's say I'm a baseball player. Every year I draw this, and people laugh at me. How's a baseball player? Well, they're hitting the ball, so I'm going to draw him like with his hands out front. He's got his bat that he swung forward. That's the baseball bat. And they're whacking the baseball. They got a hit. And so then the baseball is going to go, something like, you hit a baseball, it goes up. And so here's the ground. The baseball is going to go up, and eventually, however hard you hit it, it hits the ground. Woo. And so it's really just the graph of a parabola. And so the initial value of your baseball path is here. And so this is kind of like if we graphed it. This represents time, so this is your time axis. Time. This is the height of your baseball. Oh, can't see. And so we want to know, well, what was the height of the baseball when it got struck? Well, we start recording time when the baseball gets hit. And so this is your initial value. And in this case, that's the initial height, because the value that we're measuring is the height. And you guys hopefully know by now, initial value is the same thing as the y-intercept. And that's why last week, hopefully, some of those conversations will help with this week. So this first question is, what's the initial height of the baseball when it's struck by the bat? Well, it's just the y-intercept. And the y-intercept of a quadratic is the c value. C value. And so let's go through and label real quick our a, b, and c values. So our a value is -16, b is 80, c is 3. And so our c value in this case is 3. So the initial value is 3. There's no units. Let's call it 3 feet. Let's say the height is measured in feet. And time is measured in seconds. Sure. That seems accurate, right? Like we usually measure things in feet, and baseballs don't usually fly for minutes. So let's do seconds. So the initial height is 3 feet. Oh, and then there's seconds and feet in the problem. So the initial height is 3 feet. That's when it gets hit. And then it follows some path. And my drawing is not to scale at all, but I needed to fit on the paper. And so they want to know, what's the height of the ball after 2 seconds? Well, 2 seconds, we have to plug in to our formula. 2 seconds, that's a time value. So that means we're going to plug in for t. And so the height after 2 seconds, the height would be negative 16 times 2 squared plus 80 times 2 plus 3. So everywhere where there's a t in the equation for the height of the baseball, I'm going to replace t with 2 seconds. And then to find that number out, literally just type this whole thing into Desmos Scientific. I'm going to use my calculator so that you guys can see while I'm making my video. So negative 16 times 2 squared. Remember, don't forget your parentheses. Parentheses are important for this part. Plus 80 times 2 plus 3. 99. So the height of the baseball after 2 seconds is 99 feet. What's the height of the baseball after 3 seconds? Once we know after a couple time frames, we'll be able to figure out like how long does it take to hit the ground or whatever. We're going to piece it together. 3 seconds, we're going to do the same thing except we're going to plug in 3 now instead of 2 and compare the time. So height equals negative 16 times 3 squared plus 80 times 3 plus 3. So let's go ahead and type 3 into our calculator now. Negative 16 times 3 squared plus 80 times 3 plus 3 is also 99. Huh. So the height at 2 seconds and at 3 seconds are both 99 feet. Well, let's go look at our picture and think about why that might make sense. As you hit, as you hit a baseball, it goes up to a certain height and reaches some maximum height. So right here, I don't know what that is, but this is the maximum height. At some point it maxes out and then it starts to fall back down. So when you hit a baseball, it goes up to a certain height. Gravity then, works on the baseball and then starts to bring it back down. Well, at 2 seconds, it's at 99 feet. So let's call 1, 2. Let's call this 2 seconds. That's not exactly to scale. 3 seconds. So at 2 seconds, it's here at 99 feet. And at 3 seconds, it's also here at 99 feet. 99. And so the reason why we got 2 answers that were the same thing is at 2 seconds, it's at 99 feet on its way up. And then as it heads back down, it's also going to hit 99 feet. So that's why we have 2 outputs where there's 99 feet. There's 2 outputs actually for everything except for the maximum. So then for 100 feet, it's like 2.01 seconds. And then for 100 feet on this side, it would be 2.99 seconds or whatever it may be. So there's 2 time periods when it's going to hit a certain height on its way up and on its way back down. How long does it take for the height to reach 50 feet? Well, this time is a little bit different. This time they gave us a height. We want to know how long it took to get there. We want to know what time length did it take to get to 50 feet. First of all, I want to just guesstimate. If it took 2 seconds to get to 99 feet, my guess is, 50 is half of that. My guess is maybe somewhere around 1 second. I don't know. It depends on the velocity of the baseball, but it's going to be less than 2 seconds for sure. So the way we do this, here's our function. Height is equal to negative 16t squared plus 80t plus 3. So this time we want to solve for the t value. We want to know how long the time takes to get to 50 feet. We're setting it equal to 50 feet. 50 equals negative 16t squared plus 80t plus 3. So we want to solve for t. How do we solve a quadratic? Factor or quadratic formula. So just by looking at it, our a value is not 1. So we're definitely not going to be able to factor application problems. So we're going to end up doing quadratic formula this week for application problems. Woo! So remember, the first step to solving a quadratic is that it has to be set equal to 0. So first step, get it set equal to 0. To get it set equal to 0, I'm going to subtract 50 from both sides. So these cancel. 0 equals, bring everything else down. Negative 16 t squared plus 80t. The only thing we're moving the 50 from is from the constant family over here. 3 minus 50 is negative 47. So now we are going to do quadratic formula. So A is negative 16. B is 80. C is negative 47. So real quick at the top, I'm going to write down quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So remember, the first part I do is real quick, we're going to find the discriminant. So let's find the discriminant, which is b squared minus 4ac. So 80 squared minus 4 times negative 16 times negative 47. So again, usually you guys are using Desmo Scientific. I'm using my calculator. 80 squared minus 4 times negative 16 times negative 47. So we get the discriminant is 3,392. So let's plug everything else into the quadratic formula. In this case, we're solving for h, so I guess I'll say, t time. T equals negative b, so negative 80, plus or minus the square root of 3,392, all over 2 times negative 16. So I'm going to simplify it a little bit real quick. Negative 80 plus or minus the square root of 3,392, all over 2 times negative 16 is negative 32. So remember, find your two answers. Do plus and then minus. So negative 80 plus the square root, negative 80 plus the square root of 3,392 and divide by negative 32. So the first one is 0.679. Let's do 0.679. The second one is negative 80 minus the square root of 3,392 divided by negative 32. The other one is 4.32. So the next thing I want to talk about is let's interpret, there are two answers here, and our time is in seconds, so seconds. Why are there 2 times where it reaches 50 feet? There are 2 times when the ball is at 50 feet. Well, I told you the first one would be less than 2 seconds, right? One of them would be less than 2 seconds. So at about 0.7 seconds, about here, this is where the ball is at 50 feet. Remember, the ball hits 50 feet on its way up and also on its way down. Here's 50 feet on the way down, and this is at about 4.32 seconds. So there's 2 spots where it hits 50 feet. There's 2 spots where it hits 99 feet. There's 2 spots where it hits everything underneath the maximum height. All right. And the last question is, how long does it take the ball to reach the ground? Well, we know, 50 feet here is 4.32 seconds. My guess is probably somewhere around like 5 seconds. I don't know. So, to solve for the time that it takes to hit the ground, well, let's think about it. What are we going to set it equal to? What's the height when it's on the ground? Well, the height when it's on the ground is 0. So actually, the last part of this question is a little bit easier because we're going to take our quadratic and set it equal to 0 feet. When is it on the ground? When it's 0 feet, when its height is 0 feet. So all you have to do is just set equal to 0. And hey, look at that. It's already set equal to 0. You just jump right into quadratic formula. So we don't have to move anything around because it's already set equal to 0. Sweet. So A is negative 16, B is 80, C is 3. Find the discriminant. Discriminant would be 80 squared minus 4 times negative 16 times 3. 80 squared minus 4 times negative 16 times 3. 6592. All right. Plug into quadratic formula. T equals negative b, so negative 80, plus or minus the square root of 6592, all over 2a. So not much changes from the last problem except for the discriminant, because we're solving a different time. Negative 80 plus or minus the square root of 6592 over negative 32. So then find your two answers, add and subtract. So negative 80 plus the square root of 6592 divided by negative 32. Is negative 0.037. When we subtract negative 80 minus the square root of 6592 divided by negative 32 is 5.037. So these are the 2 times when the ball is on the ground. Height is 0. So one of them makes sense. You know, we said it probably, you know, if this is 4.32 seconds, the ground here, this is 5.037 seconds. That's how long it takes for when you hit the ball for it to hit the ground, 5 seconds-ish. But the problem is, you know, there's this other answer, this negative one. Where does this come from? Well, you know, parabolas don't exist in the real world. What we're doing is we're modeling this baseball using a parabola. But, you know, according to a mathematical model, every quadratic is an infinite parabola. So technically what's happening is this is going on forever in both directions, whether it's realistic to the problem or not. So what's happening is it's going in this direction, you know, this end of the parabola. If we graphed this function, you know, it wouldn't just be this part. We would see the arrows, you know, it would go on forever. And so, you know, this x-intercept is at 5 seconds, which is the realistic answer. But this x-intercept is down here at negative, you know, a little bit less than a second. Because technically, if you hadn't hit the ball, it would have hit the ground behind you. And so that's why it would be over here. But we did hit the ball. And so we can't have negative time. So this is actually not a legitimate solution for our application problem. This is our only answer. All right, let's try another one. Smacky the Frog launches a rocket into the air. The rocket's height in feet over time is modeled by the following equation. So in this example, I'm going to draw another picture. I'm going to draw the axes again. Now the difference is when you launch a rocket, where does a rocket start? Where do you start with a rocket? A rocket starts on the ground. How do you draw a rocket? Like with its fancy tail things. I don't know. Sure. Looks like a rocket. And it's going to launch and it's going to send it, you know, like a parabola. All the way until it hits the ground. So here's our rocket launch. So a rocket typically starts on the ground. You know, you got like the little like hose thing and you step on it and it launches it. So, you know, if you're starting a rocket on the ground, what's the initial height? Where does the rocket start? It starts at 0 feet. And to double check that, let's look at our quadratic. Height equals negative 16t squared plus 120t plus 0, right? There's no constant here. No constant. That means it's 0. So let's label our A, B, and C values. Our A value is negative 16. Our B value is 120. Our C value is 0 because the y-intercept is 0. So it starts on the ground. Next up, we want to ask, how high is the rocket after 2.2 seconds? So to figure out the height, you know, we're plugging in for time. This is a time. So plug in for t. So the height is negative 16, 2.2 squared plus 120 times 2.2. Go to your calculator. Negative 16, 2.2 squared plus 120 times 2.2 plus 0. Doesn't do anything. 186.56 feet. How high is the rocket after 3.25 seconds? I don't know. Let's find out. Negative 16. And plug this time in now. 3.25 squared plus 120 times 3.25. So type it into your calculator again. Negative 16 times 3.25 squared plus 120 times 3.25. 221 feet. So I don't know what the maximum height is, but you know, here's the maximum height it hits. After 2.2 seconds, I don't know, sure, or we'll call 1, 2, 3. After 2.2 seconds, you know, it's at 186 feet, 187 feet, sure. And then like a second later, at 3.25 seconds, it's at 221. So that means that we're we're on our way up to the max. There's also a second time where we would be at that feet because of the parabola shape. How long does it take the rocket to reach 100 feet? So let's figure out, you know, right here was 186 feet. So 100 feet is somewhere in here. So our time is going to be, you know, between 0 and 2, who knows, somewhere in there. So to figure out when it's a certain height, this is where quadratic formula comes in. We set it equal to 100. This is a height. So plug in for h, solve for t using quadratic formula. So h equals 100 now. So 100 equals negative 16t squared plus 120t. But remember, we can't use quadratic formula until it's set equal to 0. So I'm going to subtract 100 from both sides. So 0 equals, now where do we subtract 100 from over here? T squared family, no. T family, no. The constant family is 0, so I'm just going to subtract 100. Negative 16t squared plus 120t, just minus 100. So for quadratic formula, your a value is negative 16, b is 120, c is negative 100. So first up, find the discriminant. So 120 squared minus 4 times negative 16 times negative 100. B squared minus 4ac. So it'll probably be a big number. 120 squared minus 4 times negative 16 times negative 100. Exactly 8,000. So discriminant's 8,000. Let's plug the rest into quadratic formula. So t equals negative b, negative 120, plus or minus the square root of 8,000 over 2 times negative 16. I'm going to clean it up a little bit, just the bottom. Oh, if I can write. Negative 120 plus or minus the square root of 8,000 over negative 32. Plug both into your calculator. Negative 120 plus the square root of 8,000 divided by negative 32 is 0.955. Negative 120 minus the square root of 8,000 divided by negative 32 is 6.545. So there's 2 points. So like we said, the first one we knew would be between 0 and 2 seconds, and it's at 0.955. So we reach 100 feet about right here. But remember, on its way back down, we also hit 100 feet. So we also hit 100 feet here at about 6.5 seconds. So there's 2 spots where we hit 100 feet. All right, and then the last part, how long does it take for the rocket to hit the ground? Well, we start on the ground at 0, and then how long does it take to get here? Well, if this was 6.5 seconds, probably about like 7 seconds, I don't know, somewhere in there. So remember, what's the height when it hits the ground? Height would be 0, so we're going to plug in 0 for height. So 0 equals negative 16t squared plus 120t. So we're going to use quadratic formula. We already have it set equal to 0, so we're good to go. So a is negative 16, b is 120, c, if there's nothing here, is 0. So to find your discriminant, b squared minus 4 times a times c. So 120 squared minus 4 times negative 16 times 0 is 14,400. So plugging into quadratic formula, t equals negative b plus or minus the square root of 14,400 all over 2 times negative 16. So we'll plug in, find both. This is negative 32. Negative 120 plus the square root of 14400 divided by negative 32 is 0. So the first one's 0, which makes sense, right? Because, you know, your first time when you're at 0 is at 0. Crazy. And then the second one, when we do subtracting, negative 120 minus the square root of 14400 divided by negative 32 is 7.5. So then how long does it take for the rocket to hit the ground? 7.5 seconds. So the reason why there's 2 times, you know, it's a parabola. So the first time that we're at 0 is at 0 because we start on the ground. And then the second time we're at 0 is at 7.5 seconds when it hits the ground after it lands. All right, guys, so your quiz this week looks like a mix of these questions. You know, some of these first few questions are like the level 2. These ones are like the level 3. Let me know if you guys have any questions.